So, as I said, today we have three great speakers. We really work well together. It's not the whole of CivicTech, but it's I think really important topic. So the Robin will talk about Agora, which is a political organization that tries to be active politically, but is based on technological advances and civic tech. Then Alexandre Beauvais, which is from UC Louvain, so from Louvain-la-Neuve. The UNAMUR is actually a mistake, so sorry. And that will talk about the 2016 US election, which is still a pretty important topic to analyze even 3 years after. And he recently published a Nature paper, so that's important. And actually, Luc also will talk about another Nature paper. He's now at the Imperial College of London. And it's a topic which is slightly tangent to the problem of civic tech, but it's about anonymization, anonymous data. And the question is, with the scale of data we have, it's pretty difficult. So it makes sense to have a specialist talking about that, I think, in this event. So, well, thank you very much for the speaker to come, and thank you to for coming. And now I will just give the mic to Philippe so that he can introduce the digitizer.
So just a quick one. Very warm welcome to all of you. I'm pleased to see that the data science community in Brussels is alive and starting their 6th season here. When we started the first season of the data science community, we had that mission trying to communicate the value of analytics, the value of data science, and make people from that we call the other side, people from the business, understand what they could do with it. Yeah, that was mainly our challenge, and we wanted to have that in an open as possible environment. So that's why we invite anyone to come and talk and to present their findings, as long as it's not commercial. Yeah, we don't really want to have commercial pitches. And that was quite successful, because very soon after the start in 2014, we already had meetups with more than 100 people, and then we ended up at the end of that year with meetups of 250 people. Then certainly what we wanted to do is to have an event taking place during the day. So we organized the Data Innovation Summit, which will now take place for the 6th time on the end of June at the Université Libre de Bruxelles, and we were expecting about 1,200, 1,500 people. It will be more a Benelux event this year. The team will be beyond the hype. So the idea is, okay, you've talked about it, but let me see how it works. What's the value again of what you? And we will invite one country, which will be Canada, and certainly the center around Montreal, where they are very hot on artificial intelligence. So that will be for the end of June. Closer to our timeline now is we are starting the 4th data science bootcamp this Monday. The idea is to get on board people who are trained in analytics but have no real idea of how it can be implemented in a real life environment. And it's a long track. It will be a 9-month training program with a 3-month online coached MOOC environment that we are setting up here as of Monday, and then as of March there will be half-time hands-on workshops, half-time internship at the bigger organization across the street like NG, Proximus, Euroclear, and Belfius, and those companies. So that's for the start of Monday. On Sunday, quite interesting. Sunday at 9 o'clock, we are having an early morning start here. We will talk about holochain. If you haven't really get your head around holochain, you still have a lot of time, because technology is not ready there. But the whole idea is, how can you master your data? How will the data at one time belong to you, and how will it be implemented so that you can take the benefits out of your own data? Yeah. We all know that for the moment you have two models. You have the American model where the GAFAs are making all the money with your data, and then you have the Chinese environment where the government is making all the money with your data. Tim Berners-Lee has this new project, works on MIT with the MIT boys on it. But interesting, there are also two people from Belgium working, one working at MIT and the other one working at IMEC, involved in that project around holochain. So if you have nothing to do on Sunday, it's a free event, of course. That's basically all I wanted to say, except one last thing, is that we are implementing here on the first floor an environment where we will have 20 demo cases of real-life implementation of AI systems in order to allow the management from the bigger companies across the street to come here and to have an idea of what AI really is and how it can be implemented in their environment. Because their challenge is given by their boss. Their boss says, "I make sure you do an AI project before the end of the year." They have no idea what they can do with it. So we want really to have like 20 different examples here of AI projects so that they can say, "Oh yeah, now I know image recognition or NLP or sentiment analysis," so that they have those examples. Good. That's all I wanted to say. I'll be standing behind the bar for after the break, for after the presentations, and I hope you have a very good presentations from the three presenters. Thank you very much.
Thank you, Philippe. So please welcome our first speaker, Robin de Voort, who will talk about Agora. So he told me he was just a volunteer there, and that's it. So no further introduction. Yeah, please welcome him. Oh, what? That's the wrong
Parfait. Okay. Thank you. Well, good evening. I'm very happy to speak before the two presentation about Nature paper, because I would feel quite ashamed to speak after them. So I guess the night is going to be better and better. But let's start. So to be clear, I'm not here to talk about politics, although I would be very happy to do so later on with a beer. But I still need to give you a bit of the context about what we've been doing with Agora. Agora is a grassroots movement. It started less than 2 years ago. Until this summer, it was only composed of volunteers, and now it is still mostly, I mean, the most of the work is still done thanks to volunteers, and all the things that you're gonna see here have been done by people who have done that next to their full-time job because they believed in that project. What we're doing with Agora is we want to experiment, we want to push for new forms of democracy, and in particular we want to, I mean, we are actually now gathering an assembly of 89 citizens that have been randomly selected within the population. We will give them time to discuss political subject that they want to discuss, and because in last regional election we won a seat in the Brussels Parliament, we will defend in the Brussels Parliament all the decisions that assembly will make in the future. And the first day that this assembly of 89 people will gather is this Saturday. So it is quite exciting for us, and there's also a lot of work to do still. So why do we want to select an assembly of 89 people? Well, there's many. I mean, that could be a long discussion, but basically, we would very much like that everybody would participate in the politics of their region of their country. We would like every voice to be heard. We would like people to discuss with each other and to meet people that don't have the same opinion as they do. But it's quite hard to do that with more than 1 million people in Brussels. So what we're trying to do is to make a mini population of 89 people that is as representative as possible as from the full population of Brussels. And they will be there only for 1 year, so they don't have to worry about being elected, about campaigning. For 1 year, they will just think about what is, in their opinion, the best thing that they could do for the population. So that's it for the politics. From now on, I'm gonna explain how we actually did that, because selecting those 89 people that are gonna meet on Saturday was not an easy task. All right, so when we talk about a representative sample, the easiest way to do, right, is if you can take a big enough sample, is to just randomly select within the population. But the sample that we're gonna take is not that big. It's 89 people for a population of 1 million people. And there is a lot of biases that can enter the selection process, because those people still need to accept to participate. And so instead of just randomly selecting people, we have decided to force a few representativeness goals. So we want that the distribution of gender, the distribution of age, and the distribution of level of instruction, the degree that that people have, is actually exactly the same in the assembly as in the population. It's gonna be clear why we took these three later on in the presentation, but mostly it's because we know from previous experience that if we don't pay attention to those three factors, we will not have something representative. We will have more men than women that will accept to participate, and we will have more people with a higher degree, like university degree, that will accept to participate than people with no degree, for example. And you have to see that, well, actually 37% of the population in Brussels doesn't have any degree. They did not finish the first 3 years of the secondary education. So that's a big part of the population, and we want them represented as well. And then we're not doing that once. As I said, we select them and want to have them gather for 1 year. But actually, we plan to do that for the next 5 years. So during the next 5 years, we want to always have 89 people that are part of the assembly, but every 6 months, half of them are replaced by a new block, and any one person in there will only stay for 1 year. So since October, we've done the first selection, and we've selected people to constitute the first block for the next 1.5 years, and we'll have to do a second random selection later on, and then another one and another one to each time replace the people that are in the assembly. All right. Well, just a question by, did anybody here know somebody who received a letter from Agora in the past weeks, or has received a letter from Agora in the past week? A couple of people. Well, a lot of you actually, if you ask people around you, you might find out that somebody received one, because in the past week we've just distributed 6,000 letters in Brussels. So, how do we do this random selection? Ideally, we would just well, too far. That's was not that slide. So, two steps. First, we will actually send invitation. So, as I said, we send 6,000 letters to invite people to participate. But we expected that many people would refuse to participate. Previous experience told us that, well, there's about 3% of the people who were invited who actually said, yes, I want to participate. So that's why we invited 6,000 people just to create a couple of block of 89 person. And so we invite a lot of people. Some of them say yes. And then in second step, we select who among those who said yes will actually be part of the assembly. And we select them in a way that maximize the representativeness of the final assembly. All right, so how do we do the random draw? Ideally, we'd like to just ask the National Register to give us a sample of the population with their address, and that sample we could ask them to make sure that it does fit the distribution that we want of age, gender, and all that. But I mean, thankfully, getting access to the National Register is not easy. I mean, thankfully in general, but it made things a bit harder for us. We still want to have access to that in the next time we do it, because that's the best way to go. So we're working on this, but we had to find another solution this time. So the solution we found it with only open data and a lot of time. So next best thing, instead of picking people, we decided to pick addresses, because we can more easily find database of all the addresses in Brussels. But there's a problem with that, because we have all the addresses, we have the street names and the number of all the buildings in Brussels, but we don't know how many people live there. We don't know if it's a single house with one person living there, or if it's a huge building with 50 apartments with 50 families living there. And so if you only select randomly those addresses, well, those living in bigger buildings with many other people will have a lower chance to be selected. And the goal here is to give everybody the same chance of being selected. So what we had to do was to weigh the addresses based on an estimated number of people living in those buildings. And that has been like the difficult part to find a good estimation. So what did we use for that? And I'm gonna go to another place where, okay, so first of all, yeah, for the addresses, so to know the street and the number of every building in Brussels, we have that. We can take that from Urbis, and that gives us something like this, right? So here we have yes, we have a dot here for every building in Brussels. Next, we can look at the distribution of the population density in Brussels, because there are parts of Brussels where there are much fewer people living than in other parts. So what we can look at is this. So those are what we call the statistical sectors, and that's the finest the finest geographical granularity with which the official statistics of StatBel and regional statistics are made. And so those are smaller than the municipalities. And for each of those statistical sector anywhere in Belgium, we have the official number of people living there. So we'll need to estimate for each of the points that are in there the probable amount of people living there, and we'll do that. I mean, the easiest, the first approximation is to just divide up the population of statistical sector by the number of points that we have in there. But we know that's gonna pose a few problems. So what we're gonna look at now is actually the volume of the buildings. We can have that because Urbis again give you all that data. Yep. So here you can see, you can look for any building in Brussels, the volume, the shape of any building, and so from that we computed the volume, and we use the volume as a weight to give more weight to the bigger buildings and a low weight to the smaller buildings. And so instead of just dividing up the number of people living in one sector by the number of buildings, we divided it by a weighted. We divide it according to the weights of the size of the buildings. But when we did that, then we started to draw addresses. What we observed was that every single time we had the what do you call it, the Justice House, right? Because that's the biggest building in Brussels, and we also had the Royal Palace because that's also a very big building. And so we thought, okay, there are some problems over there. So what we needed to add was basically to remove all the big commercial buildings, right? You want to remove also everywhere that people don't live. There are a lot of buildings that are not residential addresses. We need to remove them. And then we don't have good data about that. We don't have a perfect way to say that is a residential building and that is not a residential building, but we have something that approximates it. Coming from OpenStreetMap. So in OpenStreetMap, people have tagged this area is a non-residential area because those are factories or those are commercial buildings or whatever. And so we took this, but we could not completely trust that, right? So we could not, because a building is within something that was tagged non-residential area in OpenStreetMap, we could not completely remove it from our selection because maybe there's somebody living there, and we can't completely give up the chance that that person is going to be invited to participate. So instead of completely removing those dots from the potential selections, what we've done is give to all of the buildings that are in those non-residential area fake volume equal to the median volume of the all the houses in Brussels. So Justice Palace, suddenly it had the fake volume of a house, and so it was not more likely to be drawn by random lot than any other house. So now we had the weights. There's a bit more tricky things messy things that I'm not gonna show you. So that's and then we can finally do the selection. I mean, that was the easy part, right? When I tried to explain that we spent the last few months trying to find a way to randomly select people in Brussels, a lot of people say, well, you just type random in a computer and that's it. Well, at some point, yes, we do it. But that's the very last step, and that's the easiest step of all. Still, we needed a random seed to do that selection, and for that we used the timestamp of the moment we clicked on the selection, but also that was done at a press conference with journalists that were there, and we selected randomly a journalist and asked them one random number, and that served as a seed for the selection. All right, so if you were not selected, you can find that journalist and talk with him, because that's his fault. Okay, so a few numbers. This is just to show that indeed, when you look at where the address were picked and the population of each municipality, well, there's a close match. So if we did not have that, that would have been a problem. So we probably have, that doesn't mean that it was good, but it's a bit reassuring. But then we had selected 6,000 addresses. We needed to distribute them. That was not an easy feat either. Because we didn't pay bpost to distribute those addresses. We needed to rely on volunteers to go there and distribute, and that's a whole other story. And then people started to reply, and we got more than 300 people that said yes, I want to participate, which is on the higher end of the of what we were expecting. And when we looked at the gender distribution and the age distribution of the people who responded, it was quite close to the actual distribution of the population. So that's a good sign. But if you look at the degree that the people who responded have, well, there you see that it was not at all like it was not at all representative of the population. So there's about 25 people among the more than 300 who responded that don't have a degree, secondary degree. And as I said at the beginning, that population is actually 37% of Brussels population. So there we have a real representative problem. And that's why we had to go to step 2, which was the selection process, which is a very interesting process that I could spend a lot of time explaining, but as I understand, I just have 2 minutes to finish, so I'm gonna cut that a bit short. It's actually not that easy to do. It's not, it's a discrete problem. You have to pick a number of people, and if you decide to take a person with no diplomas in the 89 that you want, well, that person also has a gender and an age, so it's gonna influence the other two criteria that you need to keep balanced. And so we ended up actually making a genetic optimization algorithm to solve that problem, because that's a heuristic problem. That's a heuristic solution to a combinatorial problem over there. We might have done something else. We maybe didn't need to go to a genetic algorithm to do that. Does anybody, who knows what a genetic algorithm is? All right, who doesn't know? Okay, in 2 words. Instead of trying to find immediately the best solution, you create a bunch of random solutions, and then you pick the best among those, and you combine them somehow. From those 2, I'm gonna create a third one that is a bit of a mix of those 2 plus some mutation, and you do that again and again, and that gives you a second population of potential solution that is hopefully a bit better than the previous one. And you do that again. You take 2 from that new population, 2 of the best. You mix them, so you take something that looks like a bit of both, and you do that again and again, and eventually your population, the whole population, leads up to a local minima of the thing that you try to optimize. So that's what we've been doing. Not talk into all the details of it. That's what we have in the end. So this Saturday, we'll have 89 people coming over for the first assembly with about the same number of men and women, the distribution of age that we would expect by through random selection in the population, and the distribution of degrees that is not quite what should be, but that is much closer than what we would have if we had only taken the people who had accepted to participate. So that's it, I guess. Yes. Well, so we knew that the people who did not have that diploma would be less likely to say yes. But first of all, we need to give everybody the same chance of being selected, right? So the first step of inviting people must give exactly the same chance to everybody. So we could not target more people with low diplomas. And even if we would like to do it, wanted to do it, we could not do that. But that was not the philosophy. We wanted to invite everybody. But then yes, because we knew that that people with low degrees or no degrees would answer less, we actually targeted a bit more in the follow-up, right? So some people, they just received a letter and they had to answer by themselves. Some other, we actually went to the front door, ringed, and tried to explain in person this strange letter that you received inviting you to come and discuss politics with a bunch of other people. That's what it means. And yes, it's not a mistake. You perfectly have your place over there. So that's something we did based on the statistic that we have from the statistical sector. So we know where there are more people with fewer diplomas. So yeah. 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 Okay. So that's why we needed volunteers to do that and not be post. Because actually, so an address was selected, a street name and a number, and then somebody went there, and if it was a building with 10 boxes, they had an app they had a way to select one of the 10, right? They said, okay, there's 10 boxes, give me a random number between 1 and 10. Okay, that's they read the name on the box. They wrote the name on the letter. They put it there. They entered in the app that yes, that I delivered it at this address. And then in an address, I mean, in a house or in an apartment, several people can live. And the letter said all the people who live there can ask to participate. So we might have several answers from the same address. And so in the selection process, an extra difficulty was we want only at most one person living in the same house participating in the assembly. So we had to check for that as well. All right.
I will. For questions.
Yes.
And there are other Agora people in the room, I think.
Yes. Oh, okay. Uh, then they
Okay, thank you. So, thank you very much. We can, yeah. Okay. I'm heard. I heard. So, now please welcome Alexandre Beauvais, who will. Where am I? F11. Who will talk about the 2016 US elections. And well, that's not exactly your standard like debate on those elections, so buckle up. It will be funny.
Thank you.
Thank you.
Yeah, so thank you very much for the invitation. So yeah, I'm going to talk about this work that I did on fake news in Twitter during the 2016 US election, where I tried to understand a little bit the mechanisms of diffusion of news, and also tried to see the influence actually of fake news on Twitter. But first, I would like to try to start with a little game, which is called What the Fake. And what I will do is that I'm gonna tell you some headlines that actually appeared in the news, and I want you to raise your hand if you think that this is a fake news. Okay, so the first one is an American built a homemade rocket and launched himself with it to prove that Earth is flat. So if you think that this is fake, please raise your hand. Okay, so not many hands, but a few hands. So actually, this is true. So this is the picture of this American, and yeah, as you can see, he really did it. So apparently, he's still not convinced. I think he wants to do it again. But so as you can see, also the source of this news is actually the Washington Post. Okay, the next one is an astronaut did a Facebook Live video from the International Space Station. If you think that this is fake, raise your hand. Okay, a few hands. So this is actually fake. This is this website called Viral USA that actually used an existing video recorded on the ISS and used it on their Facebook page to attract a lot of traffic. And the last one is a brewery created a beer called the Fake News Ale. Do you think it's fake? Hey, no one. Okay. Okay, yeah, it's true actually. There's really, and as you can see, the source of this news is the very trustworthy website beer.be. So what I wanted to show you is that actually it's not always easy to know if news is real or fake, and you often need some context. For example, knowing actually the source, the which news outlet is at the source of this news can be useful. So I'm going to talk a little bit about research in disinformation, but this is really something that is actually multidisciplinary. So, for example, if you want to try to understand how disinformation works, if you want to know actually, for example, why is there disinformation in the first place, you need, for example, psychology. So we know that actually all humans have a lot of cognitive biases. For example, the confirmation bias, which is simply the fact that we are much more likely to agree with the news that is aligned with what we already believe. So this plays a big role in the spread of disinformation. And another factor is what we call social acceptance. So maybe during this game, you saw that you were more likely to raise your hand or not raise your hand depending on what the people around you were doing. So this is something that is called social acceptance. So if you do the opposite of what people are doing around you, you kind of pay a social cost. And this is also something important that plays a role, especially in social media. Actually, this is also a problem for political science. So as you probably know, now we know that actually during the 2016 US election, there were Russian agents that were spreading misinformation on social media to interfere with the election. Hello. If you want to understand how it propagates, well, there's actually linguistics is also important, because fake news is often designed actually to exploit our cognitive biases, to play on with our emotions. There's actually this whole field of computer social sciences, which is very close to also data science, which help us understand all those things that we have in social media, like echo chambers. So when you have communities of people with the same belief, and we know that in those communities, misinformation is usually amplified. Selective exposure, and also the role of automatic accounts, so bots that are used also to amplify misinformation. And if you want to understand the diffusion in those networks, and also if you want to identify the most important spreaders, this is in the domain of what we call network science. This is a little bit actually what I'm going to talk about you now, which was the field of my work in a sense. So, but first, I just want to clarify something, because it's actually, I guess you understand that misleading information is actually on a spectrum, from completely false information to not really false information, but information that is used to harm people. And what we call usually fake news, what I will call fake news here, or disinformation, is really information that is false, and also that is made with the intent to harm people. So if you think about satire, for example, this is false information, but not really not made at all with the intent to harm people. So if you so actually analyzing the news in Twitter during the 2016 election, you may have seen some fake news during this time on Twitter, but there are some questions that I wanted to answer, and those questions are the following. So the first one is actually, what is really the importance of fake compared to more traditional fact-based news in Twitter? And what are the different diffusion mechanisms of this news? And also, who are the news influencers, and how do they drive the dynamics of Twitter? So to do that, we collected actually many tweets, 171 million tweets, during the 5 months that were preceding the election day. And these were tweets about Donald Trump and Hillary Clinton. And then from those tweets, we looked at all the tweets that had a link to a news outlet. And we then classified those tweets according to the news outlets in different categories. So the first one is disinformation, and the second one is what I call traditional news. And in the disinformation, I also make the distinction between really fake news, so news that is fabricated with the intent to mislead, and also so conspiracy theories and so on, and the news that are actually that I call extremely biased, which is more like opinion distorted as facts or propaganda. So for example, in the extremely biased news, you see that you have the website Breitbart. Then in the traditional news, we also then classified each news outlet according to its political orientation. So the first thing to do, of course, is simply to count the number of tweets in each of those categories. And this is what we see. So you see that actually the category of fake news and extremely biased news represent 25% of the number of tweets. So this is what you see here. But the majority is actually still in the left and left-leaning category. And what is interesting is that if you look at the number of users instead of the number of tweets, well, you see that the proportion for the fake news and extremely biased news goes down to 12%. So this simply tells you that those users are, in average, like twice more active. So we also try to estimate the importance of automated accounts, so like bots. And this is actually very complicated to identify those accounts, but a simple thing that you can do, which is not perfect, but gives you an idea, is to look at the client that was used to send the tweets, like for example your iPhone or the web client, and classify tweets if they were sent from an official Twitter client or from a non-official Twitter client. And when you do that, you see that actually there's more or less the same proportion of users that use those automated accounts across all media category, actually around 4%. But again, if you look now at the activity of those accounts, you see that for the fake news and extremely biased news, you have much more active accounts. Okay, so this is nice, but we also wanted to understand a little bit the dynamics of this system. So the next thing that we did is look at the activity of each category. So simply looking at the number of tweets per minute for each type of news and making time series. And then if we simply look at the correlation between the time series, this is what you see. So this is the matrix of correlation. And here what you see is a representation in a form of a graph of those correlation. And we see that we have two main clusters. Clearly, we have one with the center, the left, and the left-leaning news. So traditional news, but actually more left-leaning. And the other one has the right news, which is also which is together with the fake news and the extreme bias news. And those, so here you see this actually type of echo chambers where we see that those two types of news, they are not correlated together at all, but they each have their separated dynamics. And what is interesting is that if you look at also at the activity of the supporters of Trump and Clinton, their activity, if you look at the pro-Clinton, their activity is correlated only with the activity of the center left and left-leaning news outlets. But the pro-Trump, their activity is correlated with everybody. So we also wanted to understand a little bit how news spread. So looking a bit at the information flow. So we also looked at the network of retweets. So this shows you a network for the fake news and for the center news, where each dot is a user and each arrow represent a flow of information which is actually in the form of a retweet. And here, of course, I just show you the top 100 users for each network, but actually we have, when you do that for the 5 months of data, you have, of course, huge networks. But what we see, then we also looked at, we tried to look at the characteristics of those different networks, and what we see is that for the center news and also left news, we see very large networks with a small number of extremely connected users. So you see that it's those big and dark nodes here are the most connected users. But for the fake news, we see quite smaller networks that have on average a higher connectivity, so that are much more dense, as you can see here. So this suggests that the diffusion mechanisms are different for the center and the traditional news than for the fake news. So to try to understand how those news are spread, we then try to find the most important users in those networks, and to do that we use a method that is actually based on the idea of how to best destroy the network. So the idea is to find a minimal set of nodes to remove in order to completely disconnect the network. And when you do that, this minimal set of nodes represent actually the best nodes in terms of spread of information inside the network. And this is here you see the top 15 nodes for the fake news, the extremely biased news, and the center news. And what was quite interesting is that, okay, you maybe recognize some names, but also what is interesting is that if you look at the different type of news categories, you find very different profile of users. So for the actually center news, for the traditional news, you see mostly journalists or public figures, and they have almost all verified accounts. So the check mark that you see here means that this is an account that was verified by Twitter. When you look at the fake news and extremely biased news, you see some public figures, but you also see many deleted accounts. So here in black, you see the proportion of deleted accounts in the top 100 user for each category. And you see also some unverified and completely unknown people. So if you want non-public figures, so you see some example here. Those are people that actually we don't really know who they are. You can try to check on Wikipedia or somewhere else, and we don't find any information about them. But if you actually look at them, they look like real people. So this is, for example, Linda Suller, PhD. So you see that they have a lot of followers, and they are extremely active. So this is their like 130 tweets per day during the last 7 years, and they actually all also have been there for many years, and we don't know who they are. Okay, so in the end we wanted actually so we found those people, but we don't know if they really have an influence on the dynamic of Twitter. So what we tried to do is to infer this influence. So again, we looked at the activity time series for now just these top spreaders for each category, and also the activity of the supporters, and we try to infer what is called this causal effect. So we use this method of causal inference, and a causal effect means it's something that actually measures how much the activity of one of the group, so for example the fake news top spreaders, can help predict in the future the activity of another group. And if you see an arrow here, it means that there's actually a causal effect from one group to the other one. And actually what we found is that it's only the center and left-leaning influencers, so top spreaders, that really have a real causal effect on the supporters, and it's actually only on the pro-Clinton supporters. All the other ones don't have any significant causal effect, so they don't really drive the activity of Twitter. Actually, it's even the opposite. If you look at the fake news top spreaders, their activity is actually influenced by the activity of the pro-supporters, of the pro-Trump supporters. So, as a summary of those results, we saw that fake and extremely biased news represent 25% of the news volume in terms of tweets, but 12% in terms of users. And we see really two different type of news diffusion. For the traditional center and left-leaning news, we have a small set of top spreaders who are actually mostly journalists that really drive the activity of Twitter, with large diffusion network that are very heterogeneous in terms of connectivity. So it's really a picture of hierarchical global news diffusion, where you have a small set of users that really control the dynamics in the rest of the network, which is the typical picture that network scientists have in mind of how diffusion works in social media. But when you look at the fake and extreme bias news, you see actually something quite different. We have this presence of unknown top spreaders. They are actually rather following the activity of the supporters rather than driving it. And when you look at the diffusion networks, they are quite smaller, and they are also much more dense. So it's more a picture of a collective and much more local news diffusion. Okay, so this is quite nice. We find that actually the volume is quite important, but the influence in terms of activity, at least on a global scale, is not that important. But there's still a question, which is something that I didn't look at in my work, but that other people have looked at, which is trying to measure the exposure of a random person on Twitter. So because what I looked at is just the volume of tweet, but not what someone that is on Twitter would see in his feed. So there's been some work that tried to do that by taking a representative panel of Twitter users, and what they see is actually quite that. So they see that the exposure to fake news in terms of total exposure to political content is between 1% for. So here you see in blue it's the line for people that are more in the left. In black it's for people in the center, and in red it's people on the right, and here extreme right. So you see that actually it's typically below 5%, and it's only for people on the extreme right that the exposure can go up to 15%. And this also increases for people that are older, and also people that are more that see more political posts in general. There have been also some work that tried to look at this in Europe, and you see, for example, this is for French news websites, where you see here in blue the more traditional news website, and in dark blue the fake news website. And if you try to estimate the percentage of reach of those websites, you see a figure in the approximately 11%. So it's a bit less than the 25% that I saw when I was just looking at the total volume. So as a conclusion, first, we should keep in mind that research on disinformation is really something that is multidisciplinary. We saw that disinformation and traditional news have really different mechanisms of diffusion, and that although the volume of fake news is quite important, its influence and also its reach is much more limited. But I don't think that it means that we should neglect it, because fake news really fuel actually distrust in the media, and we also know that it's the result of organized campaigns. So I think we should really take it seriously. And I just wanted to say that I think that what we need to do is really to develop new tools that really empower users and also journalists to tackle disinformation. And we need to rethink the design and maybe also the responsibility of social media platforms, because for now they are basically designed to exploit those cognitive biases that I mentioned at the beginning. I think we could try to instead design them to help us fight those biases. And yeah, thank you for your attention. Happy to take questions.
Thank you. Any question? Again, short, one, two questions. We have a bit of time.
Yeah.
Yeah.
So we didn't classify users. We classified the news outlets. Yeah. So your question is about the sources. Yeah. So we classified the tweets according to the news outlets they were pointing to, and to classify the news outlets, we used a classification made by media experts that try to assess this bias. Yes. Yep. This. So this is not my work. But so how they measure this? So they really try to pick. So they pick a number of Twitter users, and they ask them actually to give their name and everything and verify who they are to make sure that they represent the demography of the US. Yeah. Here? Yeah. You mean this? So here when you see this arrow, it actually measures how much knowing the activity of this group helps you predict the activity of this group. So in a sense, it tells you if actually this means that when people in this group start tweeting, so typically journalists, then a little bit after, this group will start to react, and also their activity will increase. So it tells you that this group has an influence in terms of generating activity on this group.
Okay. Yeah. So I'm sorry. It's really we are already a bit late. So yeah. Thank you very much again.
Thank you.
And you'll stay also for a drink so people can jump on you and yeah. Okay. Thank you very much. So that was I mean, weirdly connected in my opinion, those two talks. And now we are taking a step back to anonymization and this kind of privacy problem with Luc Rocher in our age of big data and everything. In order to have access to the data that is presented here, I mean, it's maybe I don't know. Where is the button to actually? Oh, so we can already do that, and then. Oh no, that's not what I wanted to do.
We can, yeah.
There we go. It's kind of
we
okay.
can do like this. Yeah. Thanks for having me, and thanks for staying for the last presentation. So my name is Luc Rocher. I'm a researcher at Imperial College, and I work on studying the limits of data anonymization. And just to, how can I go to the next slide when it's like this? I can go down. Okay, we'll do this. All right. Yeah, that's okay. I will do like this. Yeah. Thanks. when we talk about using data, it's always a question of a balance. On one side, we have this increasingly useful data, and I think when I talk to an audience in data science and civic tech here, I think we all agree that data is highly useful, increasingly useful. It can be used to study transportation in cities, to fight epidemics, to study poverty using mobile phone metadata. But all these data that are used for social change are also highly sensitive. And privacy here is really about this balance between using sensitive data and protecting people's privacy. Arrows in the button? And now we're stuck. Yeah. All right, I'll say like this. So for instance, this is an example of data that can be collected and used for good. For instance, every places I shop to will potentially collect how much I shopped, what produce I bought, at which time. When I go online and I search on search engines, when I visit websites, this data can be collected and used to study what people browse online and why. When I use my mobile phone, my telecommunication companies might collect my behavior, all the places I go to, who I talk to, at which time of the day. And this data can be highly useful for researchers and companies. And one way often this data is shared is anonymously. For instance, in these three examples here, there is no name, there is no address, there is no phone number. However, I might be a bit scared that this data would be used. But when you say you don't want to be tracked within this data, people will respond that is fine. No one knows who this user 142 who's been searching online. The data is safe. It's anonymous. However, and it's also reinforced by anonymization being a legal standard in Europe, but also abroad. For instance, the GDPR, the new General Data Protection Regulation in Europe, states that anonymous data is not personal anymore, meaning when you have anonymous data, when you collect and use anonymous data, it does not belong to people anymore. You don't need their consent to share and use their data, with similar terms, for instance, in CCPA in California. And there's of course a long history of techniques to try to anonymization, to try to anonymize data. While anonymization is a legal standard, de-identification techniques are going to be used to try to anonymize the data and share it widely. For instance, let's say you're a clinic in France, and you work trying to do testing for STIs. In universities, so you go and test students. You will collect sensitive information about students. For instance, in this department, we tested these people. Some were tested positive for HIV, some were tested negative. This data can be used to report to the people whether they were tested positive or not, but could be used also on average to study HIV in a whole city. Of course, as a clinic, you cannot share this data with researchers. This is highly sensitive data. You might, however, try to anonymize it and share it with researchers. The first step, of course, is to try to remove every direct identifier, name, phone number, addresses, and replacing, for instance, names with a unique identifier. However, you might think that is still too much. So you will also look at the data and potentially replace date of birth by the year of birth. And you would end with this data set with no direct identifier, some coarsen, noisy data, gender, year of birth, the university and department where the testing was done, and results of a test. And you might think this data with a few steps. You pseudonymize the data, you generalize, and potentially also you release only a small sample of the data, let's say 1%, is anonymous, and you will share it with researchers who can do useful science on this data. However, when you look at all these techniques, pseudonymizing the data, removing name and addresses, generalizing and coarsening the data, releasing only a small sample, there's always a lot of cases where this sort of anonymous data was found not to be anonymous, actually. From browsing, viewing data on Netflix, searches on AOL, travel histories, in Australia, health data in Australia. All these cases in the press, which have been disclosed, were cases where anonymous data was actually not anonymous, and researchers, journalists, found out that the techniques used to anonymize data were not up to the standard, down to the point where actually Donald Trump tax records were identified recently by the New York Times. And you look in the article, they say basically they were able to access an anonymous data set published by the IRS in the 90s, and found this anonymous data using few information they knew about Donald Trump, his actual tax records. And when you tell people that, well, anonymization might not work, there's always this debate between, on one side, people who say no, the identification techniques, when used correctly, do work. It's some say it's a smart and contemporary response to the challenges of big data. And on the other side, you have people, researchers, journalists, who claim that it is actually an outdated toolkit. It might have worked well in the past, a few decades ago, but increasingly with the mass of information collected about us, it is very difficult, increasingly difficult, to correctly anonymize data. And as researchers, we really look at this question, whether the identification is actually working or not. In the past, people were, for instance, thinking that simply pseudonymizing the data, removing name, addresses, phone numbers, was a good first step to try to anonymize data. What colleagues at Imperial College found was actually using large-scale mobile phone metadata, that only a few pieces of information in so-called pseudonymous data can be used to identify someone. So when you look at people's mobility pattern in mobile phone metadata, 4 places, approximately 1 square kilometer, 1 hour, where I was, could be able to identify 95% of the people in a data set of 1.5 million people over 15 months. With similar results, for instance, using credit card transactions, knowing 4 shops and days I was there, can identify 90% of the people in a data set of 1.1 million people of shopping patterns. However, when you show these results, people say, of course, the data is too fine-grained. You need to coarsen the data, make it less identifiable. So in this case, we did the same. Instead, for instance, like it was done in the past, instead of releasing the date of birth, we could release the year or the decade of birth. Instead of releasing the zip code, we could release the postal code or the postal district. We did the same with mobile phone data. Instead of releasing 1 square kilometer, 1 hour, what if we release 2 square kilometers, 2 hours, or even more coarsen? What we found out is that, yes, it helps a bit to coarsen the data, add a bit of noise, but even if you coarsen a lot of data, down to 10 square kilometers, 12 hours, you only need a few more points to identify people. Basically, with 10 points instead of 4, you would identify 60% of the people in this highly noisy coarsened data. Meaning that these techniques, trying to pseudonymize and generalize the data, don't really work well for such large-scale data sets. However, when you show these examples, people respond that, like, fine, you may have found that, like, anonymization, the identification techniques don't work that well, but there's always a last line of defense. Because the data is anonymous, there is no name, when you find a potential match in anonymous data, you might not find the right person. This could always be someone else who shares the same characteristics as you. And because you only have access to a small fraction of a larger data set or population, it creates uncertainty that any particular person is even included in the data set. This is, for instance, a quote by the Australian agencies, the equivalent of the Information Commissioner in Australia, the Data Protection Authorities in Australia. This adds uncertainty as to whether a single person is in the data or not. To give you a simple example, in 1997 there is this highly popular case of the governor of Massachusetts who accepted to release these data sets, medical data sets of 135,000 state employees in Massachusetts. Medical records collected by hospitals and by these insurance companies, anonymous data, of course, with a few demographic information, and also medical data, health records, diagnosis procedures, etc. And back in the time, a then PhD student, Letitia Sweeney, searched for the governor of Massachusetts in this data. And she knew from public information where he lived. He lived in Cambridge in Massachusetts. She knew his birth date, and she knew also his gender. And based from this three information, she found out in the data there were 6 people with this particular birth date, 3 were men, and only 1 was living in his postal code. So she took the data. It was in '97. She put it in a floppy disk, and she shipped it to the governor of Massachusetts. We found out that yes, the data was not really anonymous, of course. However, even in this case, there are people who claim that there is a fatal flaw in this example. Basically, because the data was only a sample of the larger population in Massachusetts, these records belonging to the governor of Massachusetts could actually have belonged to someone else who was sharing the same postal code, the same gender, and the same date of birth. There might be other people in the population who share this same information, so you never know whether you have re-identified the governor of Massachusetts or someone else. And because of that, well, anonymization techniques work quite well, because you're never sure you have identified the right person. And so as researchers, we really look at this question. Can we quantify the uncertainty? How likely are we to have found the right record? Very intuitively, if 3 people share specific information, share my characteristics, if I find someone with this information, I have 1 chance out of 3 to be correctly identified. So what we did is we built a model to try to quantify how many other people share my information and how likely an adversary, for instance, someone who tried to identify, is gonna be to find the right record in anonymous data. We design a model from few hundreds of thousands of individual level records. It can extrapolate to a larger population. Let's say all the people living in Belgium, and learn how the data is distributed in the joint population of Belgium. And learn 2 things. One is, on average, how many people are going to be unique and always correctly identified based on their characteristics. And second, for a specific person, what is the likelihood to be identified? And I don't have many math and equations in my slides, but very briefly, what we do is we really model the probability for someone to be correctly identified in a population of n people. N could be 10 million people for Belgium, knowing that a match has been found based on someone's characteristics. If I find someone based on their zip code, the date of birth, and then gender, how many people share these characteristics in the whole Belgium, and therefore, how likely are they to be unique and always correctly identified? So we design a simple model that can take a few 100,000 sample of records, for instance, census data, and extrapolate to the complete population, doing 2 things. One is looking at the distribution of each attribute from a few sets of records, let's say postcode, date of birth, house ownership, and marital status. We extract the distribution of each attribute separately, so the age pyramid, how many people per postcode, etc., and we look at the association patterns between variables. For instance, if I know your postcode, I don't have any more information likely on your date of birth, because these 2 information are not really well correlated. However, if I know you own a house, you're likely more older than someone who don't own a house. So house ownership and date of birth are quite correlated together. And so we build this model that combines the distribution of each attribute and association patterns between them to build a general model of a population. And to really basically estimate whether someone is going to be unique in a population or not. And just to give you a few facts, we tested this on a few hundred datasets from both datasets in Europe and outside Europe, census survey data. And what our model does very well is actually predicting whether someone is going to be unique or not. And to give you a small examples, if we say someone is unique with more than 90% chance, we're gonna be wrong around 8% of the time. 95% wrong 5%, 99 1% of the time. So it's quite accurate at predicting whether someone is gonna be unique or not. And we went back to the example of the governor of Massachusetts and this fatal flaw. And we took data from the time, from the 90s. We trained our model that we designed. And we looked at the male living in Cambridge. His postal code was 0211132. He was born on July 31st, 1945. What was his chance of being unique? And therefore always correctly identified. And the model gave him a score of 58% chance of being unique, a bit less than the rest of the population. So yes, there could have been a possibility that someone else was sharing his characteristics and therefore the data not being him. However, if there were a few more bits of information, let's say number of children in the medical records, he had 5 children in the time, which was quite unique, 5 children. And so combined, he would have had 99.97% chance of being unique, and therefore always correctly identified. And here we see that like a few more bits of information are likely gonna like identify someone very well in these cases. We designed this website unfortunately only for the UK and for the US, but you can check with your own data, and you can give your a few statistics of a few characteristics and see whether it's actually like likely to uniquely identify you and therefore make your anonymous data not so anonymous or not. For instance, in the case of someone living in northwest London, this fact by itself is quite, there is not much information. A lot of people live in northwest London. When you add the date of birth, the fact that this is a female, you go up to 59% chance of being unique. If you add that this person is married, she's a full-time employee and she owns 1 car, with this information you have 95% chance of finding the person you're searching for. And if she owns a house, you up to 99% chance. Of course, every more piece of information is leading you to a place where you have so much information that, like, yes, there's likely only 1 person in northwest London born this date with a female, married, full-time employee, 1 car, and own a house. And then, therefore, this argument that you're never sure you have identified the right person doesn't work very well. We showed, for instance, that, like, yes, the more attributes, the more information you know about someone, the more likely you are to identify them correctly. For instance, in the US, knowing 15 demographic attributes would, on average, identify correctly 99.98% of the people. Therefore, virtually everyone. Of course, you might think that like someone who knows 15 demographic attributes about you is quite a lot. It takes a lot of effort to know 15 demographic attributes about me. However, there's so much data being collected about us that, like, compared to the mass of information available, it might not be that much. If you look at the Cambridge Analytica data that were collected a few years ago, they had on average 5,000 data points per person for 230 million Americans. And of course, this could not be the same sort of information. Still, there's increasingly more information being collected about us, making such anonymization techniques weaker than what they were expecting. And just to finish here, the message, the goal I want to say is like yes, anonymization techniques are quite hard, and there's likely and will likely never be a single silver bullet. There's a lot of techniques that can be used, but anonymization by itself is getting harder and harder to do. And we might have to move to different techniques to share and use widely sensitive personal data. We need new techniques. For instance, instead of collecting data, trying to anonymize and release it to society, to researchers, what about keeping the data in interactive platforms where we can audit what happens, how the results are aggregated, and who accesses? And also, second thing is trying to be more transparent. There's a lot of cases where companies, organizations collect and disclose anonymous data. And if we wonder like how anonymous this data is, it is difficult to answer this question. And so we need to be more transparent to be able to to use widely personal data for good. Thank you.
On time, perfect.
Ha.
Questions?
Yes. Mhm. Yes, this is a very good question. The question being whether this data can be used, like also, yeah, for bad or for trying to re-identify actively people. First, I would like also to say something I haven't said. That like in a few countries, when we talk about the risk of anonymization, the response and the legal response is to criminalize re-identification, making it illegal, especially for researchers, to try to re-identify people. Which I believe is not the right way to move forward. But I think it's the same as in security or other fields. When we show that like a technique does not work, yes, you can create harm, but it's also very important to tell people that like their data is not protected to the standard it should be, and that we need to find better ways to use this data. And I hope with this research that it is used to show that like yes, we need better techniques to share personal data.
Other questions? We have a bit of time, but I think everybody's thirsty. So let's thanks again, Luc. Oh, there was no. Okay.
I had a quick last advertisement.
Yeah.
So at Imperial College, in partnership with MIT, we work on a project called Opal for open algorithms. It's actually a project to try to use mobile phone metadata at scale. Instead of like trying to anonymize this data stays on the server of the telecommunication companies, and researchers can ask questions and obtain aggregated answers. And we're actually looking for a CEO in Brussels, I believe. So if you have you or a colleague interested in using data for good, you can talk to me after the talk. Thank you.
Thank you. Thank you very much. And thank you again for all the speakers. I really enjoyed myself. I hope you enjoyed yourself too. Now that's the second phase of the evening. So as I said, Bain is offering drinks, but also offering food. So the pizza arrived. So you're welcome to stay for that. And the two benefactors here can talk to you over there. They are very nice, so don't be shy. Thank you very much.